Scientists thought they had the Great Basin figured out. Then, satellites detected the ground moving. Earthquake sensors uncovered hundreds of active faults beneath Nevada. Ancient shorelines appeared high on mountain slopes, proving massive inland seas once covered the desert. Underground imaging revealed unusually hot mantle rising beneath the region. And recent geological research has shown that the Great Basin isn't a dead landscape. It's still evolving today. Spanning nearly 210,000 square miles across Nevada and parts of Utah, California, Oregon, Idaho, and Wyoming, the Great Basin is now considered one of North America's most active geological laboratories. Today on DiscoverTube, we're uncovering the discoveries that completely changed what scientists thought they knew. Because beneath one of America's emptiest landscapes, the ground has never truly stopped changing. Topic 1. America's only giant basin with no escape. The Great Basin is one of the few places on Earth where almost every drop of water becomes trapped. Unlike rivers flowing toward the Pacific or Atlantic, water here never reaches an ocean. Scientists call this an endorheic basin, a closed drainage system where rivers terminate in lakes, playas, or underground aquifers instead of flowing to the sea. That simple difference shaped everything. Over millions of years, minerals accumulated instead of washing away, creating enormous salt flats across Nevada and Utah. Satellite imagery clearly reveals hundreds of enclosed valleys separated by long mountain ranges. But these dry basins weren't always deserts. Ancient shorelines visible from space revealed an astonishing discovery. 20,000 years ago, much of the Great Basin was underwater. Topic 2. A lost inland sea larger than entire states. During the last ice age, cooler temperatures dramatically changed the American West. Lower evaporation allowed water to accumulate faster than it disappeared. The result was Lake Bonneville, covering nearly 20,000 square miles, and Lake Lahontan, stretching across much of northwestern Nevada. Today, Great Salt Lake, Pyramid Lake, and Walker Lake are only small remnants of those enormous inland seas. Scientists didn't guess this. Ancient beaches remain etched into mountain slopes hundreds of feet above today's valleys. LiDAR surveys and high-resolution elevation models have mapped these shorelines with remarkable precision, confirming just how immense these lakes once were. Then, around 14,500 years ago, Lake Bonneville catastrophically overflowed at Red Rock Pass, releasing one of the largest known floods in North American history. Within only a few thousand years, those inland seas vanished. But their disappearance revealed another mystery. Why did this region contain hundreds of giant valleys capable of holding so much water? The answer wasn't climate. It was the Earth's crust itself. Topic 3. GPS proved the Great Basin is still stretching. Modern GPS stations measure something almost impossible to notice. Every year, parts of the Great Basin move by only a few millimeters. Yet those tiny movements confirm the region is still stretching today. The Great Basin forms the heart of the Basin and Range Province, where the continental crust has been slowly pulling apart for millions of years. As the crust stretches, enormous fault blocks sink to form valleys, while neighboring blocks rise into mountain ranges. This process created more than 400 distinct mountain ranges, making the Basin and Range one of the most rugged geological provinces on Earth. Satellite measurements show the process hasn't stopped. The landscape continues changing, millimeter by millimeter. If the crust was still moving, scientists expected earthquakes to confirm it. They did. Topic 4. Nevada is one of America's most active earthquake states. California gets most of the attention, but Nevada experiences thousands of earthquakes every year. Most are too small to feel. Yet seismic networks operated by the US Geological Survey continuously record them, allowing researchers to map hidden faults beneath the desert. Some of those faults remained completely unknown until modern monitoring systems detected repeated seismic activity. Others became famous after powerful earthquakes permanently changed the landscape. In 1954, the Dixie Valley and Fairview Peak earthquakes produced fault scarps rising several meters in only seconds. Entire sections of Nevada were lifted and dropped almost instantly. Those events proved something important. The faults creating today's valleys remain active. Every earthquake provides another piece of data, helping scientists understand how stress moves through the Basin and Range Province. But earthquakes weren't the only clue. Geologists noticed something else hidden throughout Nevada: thin layers of volcanic ash. Those layers would eventually reveal one of the region's oldest secrets. Topic 5. Ancient ash revealed forgotten supervolcanoes. The volcanic ash looked ordinary. Under a microscope, it became extraordinary. Across Nevada, geologists discovered thin ash layers with identical chemical fingerprints. Laboratory analysis matched them to gigantic volcanic eruptions that occurred hundreds of miles away, including super eruptions from what is now southern Idaho and surrounding volcanic fields. Those ash layers became precise geological time markers used to date rock formations across the Great Basin. Some eruptions expelled hundreds of cubic miles of volcanic material, blanketing much of the western United States. Without those ash deposits, scientists would struggle to reconstruct millions of years of the Great Basin's geological history. But the volcanoes left behind something even more valuable: heat. And surprisingly, that heat is still rising today. Topic 6. One of America's largest geothermal systems. Nevada isn't just famous for deserts. It's also one of America's leading producers of geothermal energy. Researchers have identified hundreds of geothermal systems across the Great Basin, where groundwater circulates through deep fractures, heats against hot rock, and returns to the surface as boiling springs and steam fields. Some geothermal plants now generate enough electricity to power thousands of homes. The reason is simple: the stretching crust became thinner. That allowed unusually hot mantle rock to rise closer to the surface than in many other parts of North America. Every hot spring, every steam vent, and every geothermal power plant points to the same conclusion: the earth beneath the Great Basin is still releasing heat. But groundwater flowing through those fractures created something else: an underground archive. Quick question for the DiscoverTube community. Before watching this video, did you know the Great Basin was still stretching today? Or did you think it was just another quiet desert? Let us know in the comments. We read every one of them. Topic 7. Caves recorded thousands of years of climate. While satellites studied the surface, caves preserved the past. Inside Lehman Caves and other limestone cave systems, scientists discovered stalagmites and stalactites that grew one microscopic layer at a time. Each layer trapped chemical evidence of ancient rainfall, drought, and groundwater conditions, creating a climate record stretching back thousands of years. Scientists compare them to tree rings made of stone. By analyzing oxygen isotopes inside the formations, researchers reconstructed periods of extreme drought, wetter climates, and shifts that occurred long before written history. The caves also protected ancient pollen, bones, and plant remains that had disappeared from the surface. Together, they revealed an environment that looked nothing like today's desert. Yet an even more surprising climate archive was discovered outside the caves. It came from a small animal most people never notice. Topic 8. Tiny rodents preserved 40,000 years of history. One of the Great Basin's greatest scientific discoveries wasn't made by humans. It was made by pack rats. These small rodents collect nearby plants, seeds, leaves, and twigs before storing them inside sheltered nests. Over thousands of years, their crystallized urine hardened into a natural cement, preserving entire ecosystems in remarkable detail. Some pack rat middens are over 40,000 years old. By identifying the preserved plants inside those nests, scientists discovered that valleys now covered by sagebrush and desert once supported cooler forests filled with very different vegetation. As temperatures changed after the Ice Age, entire ecosystems migrated across the Great Basin.
Pack rats unintentionally created one of the longest continuous environmental records in North America. If you're enjoying discoveries like these, subscribe to DiscoverTube. Every week, we uncover the hidden science behind places most people think they already understand. But pack rats weren't preserving the oldest record. That title belonged to a tree growing high above the desert, one that has been recording Earth's climate for nearly 5 millennia. Topic 9. The world's oldest trees recorded. 5,000 years of climate high in Nevada's White Mountains grows one of Earth's oldest living organisms, the Great Basin bristlecone pine. Some trees are nearly 5,000 years old, making them older than the Egyptian pyramids and Stonehenge. Scientists use their annual growth rings to reconstruct rainfall, temperature, drought cycles, and volcanic events with year-by-year precision. Wide rings indicate wetter years. Narrow rings reveal severe drought. By combining thousands of overlapping tree ring records, researchers built one of the longest continuous climate timelines in North America. Those records confirmed what cave formations and pack rat middens had already suggested. The Great Basin has repeatedly transformed. Deserts became forests. Lakes expanded. Lakes disappeared. Entire ecosystems migrated hundreds of miles. But climate was only part of the story. Scientists eventually discovered the landscape had been changing for far longer than the Ice Age, hundreds of millions of years longer. Topic 10. Nevada was once under a tropical ocean. More than 500 million years ago, there was no Great Basin. Instead, much of Nevada lay beneath a warm tropical sea. Marine fossils found throughout the region, including trilobites, brachiopods, corals, and other ancient organisms, prove today's mountain ranges once formed the floor of an ancient ocean. Over millions of years, countless shells accumulated on the seabed. Those sediments hardened into thick limestone layers. Later, powerful tectonic forces lifted those ancient seabeds thousands of feet into the air. Today, hikers crossing remote Nevada mountains are literally walking across what was once an ocean floor. Few American landscapes have experienced such dramatic transformation. Ocean, mountains, Ice Age lakes, modern desert. Each chapter completely rewrote the landscape. But one geological process also created something of enormous value: minerals. Topic 11. The Great Basin became one of America's richest mineral provinces. Nevada produces more gold than any other US state. That's not a coincidence. As magma rose through fractures beneath the Great Basin, it heated groundwater circulating deep underground. Those hot fluids dissolved gold, silver, and other metals before depositing them inside faults as temperatures dropped, gradually forming rich mineral deposits over millions of years. Recently, another resource has drawn even greater attention: lithium. Ancient lake beds across the Great Basin contain significant lithium deposits, formed as volcanic ash weathered into enclosed lakes. Because those lakes had no outlet, evaporation concentrated the mineral over millions of years.
Today, lithium is essential for electric vehicles, smartphones, and large-scale battery storage. Forgotten desert valleys have become strategically important to governments and mining companies around the world. Yet satellites were revealing something even more surprising. The landscape itself had never stopped moving. Topic 12. Scientists discovered the ground is slowly sinking. For decades, scientists assumed most changes in the Great Basin happened over millions of years. Modern satellite radar revealed something happening much faster. In several parts of Nevada and Utah, the ground is slowly sinking, not because of earthquakes, but because of groundwater. Using INSAR satellites, researchers detected land subsidence measuring several centimeters in some locations over only a few years. As groundwater is pumped from underground aquifers faster than nature can replace it, sediments begin compacting. Once those layers collapse, much of the lost storage space can never recover. From space, the movement is almost invisible, but radar satellites detect it with remarkable precision. Scientists now use these measurements to monitor water resources, infrastructure, and future drought impacts across the Great Basin. The discovery also highlights something important. The landscape isn't changing only because of natural tectonic forces. Human activity is now becoming part of the geological story. And while satellites were measuring changes at the surface, they were also uncovering hidden features no one knew existed beneath the desert.
Topic 13. Satellites changed everything. For decades, scientists believed they had already mapped the Great Basin. Modern satellites proved otherwise. Using LiDAR, INSAR radar, high-resolution elevation models, and continuous GPS networks, researchers discovered hidden fault scarps, ancient river channels, ice-age shorelines, and subtle ground movements invisible from the surface. Some active faults had remained completely buried beneath sediment. Others turned out to be much longer than previously believed. INSAR satellites can now detect vertical ground movement, measuring only a few millimeters per year. That level of precision transformed how geologists monitor the Basin and Range Province. Have you ever visited Nevada or explored the Great Basin? Tell us in the comments. We'd love to know where you're watching from. But satellites still couldn't explain one final mystery. What was driving all of this from below? Scientists found the answer by looking deeper than anyone ever could. Topic 14. Seismic waves revealed the hidden engine below. Scientists had mapped the faults. They had measured the earthquakes. They had tracked the moving crust. But one question remained. What was supplying the energy? The answer came from seismic tomography, a technique that uses earthquake waves to create three-dimensional images of the Earth's interior. As seismic waves passed beneath the Great Basin, researchers discovered an unusually warm, low-density mantle extending beneath much of the Basin and Range Province. Because seismic waves travel more slowly through hotter rock, scientists could identify regions where heat from deep inside the Earth was weakening the crust. That discovery connected decades of research. The warm mantle helped thin the crust. The thinner crust stretched more easily. Stretching created faults. Faults generated earthquakes. Those same fractures allowed geothermal water to reach the surface. For the first time, scientists weren't looking at separate discoveries. They were looking at one connected geological system operating from the mantle to the surface. But the evidence didn't stop underground. It was still visible from space. Topic 15. Satellites are watching the Great Basin change in real time. Today's satellites don't just create maps, they monitor change. Using INSAR radar, scientists can detect ground movement, measuring only a few millimeters per year across vast areas of the Great Basin. Continuous GPS stations confirm that some mountain ranges continue rising, while neighboring valleys slowly sink. Researchers also monitor active earthquake faults.
ground deformation, groundwater-related land subsidence, expanding dust from dry lake beds, changing lake levels, snowpack across mountain ranges. Every new satellite pass adds another layer of information. Instead of viewing the Great Basin as a static desert, scientists now observe an active landscape responding to tectonics, climate, and groundwater changes simultaneously. The region has become one of the best natural laboratories on Earth for studying how continents evolve. If you're fascinated by hidden science like this, subscribe to DiscoverTube. Every week, we explore remarkable discoveries that are changing what scientists know about our planet. Conclusion: the desert that never stopped evolving. For generations, the Great Basin was dismissed as an empty desert. Modern science tells a completely different story. Satellites revealed a landscape that is still moving. GPS confirmed the crust is continuing to stretch. USGS seismic networks record thousands of earthquakes each year. Ancient shorelines prove inland seas once covered much of the region. Geothermal fields reveal heat still rising from deep inside the Earth. Packrat middens, cave formations, and bristlecone pines preserve one of North America's longest climate records. Marine fossils show today's mountains once lay beneath a tropical ocean. And valuable deposits of gold and lithium demonstrate how millions of years of geological activity continue shaping the modern world. What once appeared empty has become one of the most scientifically important landscapes in North America. Not because of a single discovery, but because every new study, from satellites in orbit to seismic imaging deep underground, reveals another piece of an enormous geological puzzle that scientists are still solving today. Thank you for watching DiscoverTube. If you enjoyed this investigation, consider subscribing so you don't miss our next deep dive into Earth's hidden mysteries. Now we want to hear from you. Which discovery surprised you the most? The vanished Ice Age seas? Nevada's hidden earthquake network? The warm mantle beneath the Great Basin? Or the fact that satellites can measure the desert moving by just a few millimeters each year? Let us know in the comments below, because sometimes the world's greatest discoveries aren't found in unexplored places. They're hidden beneath landscapes we thought we already understood. The more scientists explore the Great Basin, the more questions emerge. If you enjoyed uncovering these hidden discoveries with DiscoverTube, make sure to subscribe for more videos exploring the world's greatest scientific mysteries. And tell us in the comments, which discovery surprised you the most? And what hidden place should DiscoverTube investigate next?